Now, I'm just going to talk about the input-output validation using a Turing test. This Turing test is a qualitative test, actually. So when no statistical test is applicable, okay, you cannot run any statistical procedure, statistical test, the subjects with system knowledge can be used to compare model output to the system response, it says. So let's just explain the Turing test. Let's just say we have original system response collected for 5 days. They are in the Excel sheet. So we have 5 pages. In each page, we have the system data that belongs to 1 day. And these are real system data. They are coming from the real system, not the model. And suppose further now, we have built a model of this system and we have generated the output data from the model again for 5 replication days. So I have 5 fake data coming from the simulation model and 5 real data coming from the original system. Now I have 10 pages. I am going to shuffle them. Then I am going to give these 10 pages to the people who are involved in the system, who have the system knowledge. For example, I will give this paper to the manager of that system or the people who are working in the system. Now, I need to give these pages or give these reports in the same format. They should be in the same format. So by looking at format, they should not be distinguishable. Then I give these reports to the test subjects, and the test subjects are going to identify which reports are coming from the original system and which reports are coming from the model. If they can make this separation perfectly, or maybe they can make one error, for example, they can separate 4 original system data here, but including 1 simulation model data, and the remaining 4 simulation models to the other side, and unfortunately including 1 system data in there. Again, this means they are statistically able to distinguish the real data from the data obtained from the model. But when you repeat this experiment for different people with system knowledge, if they cannot distinguish these data groups, okay, if they cannot distinguish these reports into 2 different classes, for example, if we have 3 to 2 in each group, then this means they do not understand the difference between the original system data and the data obtained from the model. So this seems, the outputs seem to be similar, so they cannot distinguish which reports are coming from the original system, which reports are coming from the simulation model. So if the test subject cannot identify the fake reports, which one are fake and which one are real, then the test provides no evidence of model inadequacy. So we can say that the model is adequate to imitate the real system. So this is called the Turing test. It's basically a test that is made qualitatively on the people with the system knowledge.